So I wrote a few things down regarding the photoelectric effect, both conceptual and its applications. So we can start here, and this right here explains pretty much the whole, like the core of the photoelectric effect. And the photoelectric effect basically happens when a photon with enough energy strikes an electron on a metal surface to then dislodge the electron with enough energy, and for the electron to be ejected at a certain velocity, and having a kinetic energy. And the kinetic energy is equal to the energy of the photon subtracted by the energy required to dislodge the electron, which makes sense algebraically because the energy of the photon has to equal the sum of the kinetic energy and the energy that's required to dislodge it. So that's pretty much the core concept that you have to understand to like move on further into like more stuff regarding the photoelectric effect. Right here is just a little something that explains why the photoelectric effect is important, because it is what gave Albert Einstein his Nobel Prize in 1921 for his 1905 paper on the photoelectric effect. And the big thing from it that was obtained was the duality of light. That light can be a wave because of the double slit experiment, but also a particle because of the photoelectric effect. So say this photon, right, has enough energy to dislodge this electron, and say these little dots here are all photons. And all of these, this is a little much, but all these photons add up to, individually, they're small, they have less energy, but all of them add up to the same amount of energy as this photon. But no matter how many of these photons I throw at this electron, it's not going to be dislodged because light is quantized, not continuous. And if it were continuous, then that would mean it's behaving like a wave. So some applications of the photoelectric effect, one of them is the charge coupled device, or the CCD. And this is used in astronomy or photography and whatnot. And this is using kind of the same concept as far as dislodging electrons with photons. So let's say a photon were to hit and dislodge an electron on this surface of silicon. Now, instead of this dislodged electron just flying off, this time it's going to be captured by this positively charged capacitor. And then in the end, the number of electrons collected by the capacitor will be represented by the voltage. Now, all this is going to be collected, and all this information is going to be sent as information to the computer, and then eventually it'll form, using this information, it'll form a pretty picture. And this is very often used in astronomy. I believe Hubble also uses CCDs. And of course, the infamous solar panels also use kind of this concept of dislodging electrons with photons, the photoelectric effect. And this is called the photovoltaic effect. And what you need is a material with an inbuilt electric field. So this electric field is, let's say, is going to the right, and we need a photon coming in to basically dislodge an electron right here. And it's going to leave a little gap here. So all the blue is gaps like where the electron was dislodged. Well, we'll get to that. But then once it's dislodged, there's a gap left, and the electron will move over here because it's opposite to the electric field. Now, this right here is going to be filled by another electron that's bonded. And that'll be filled, then that will push the gaps all the way to the right, thereby creating a voltage. So you have a negative side, positive side. So now you have somewhat of like a circuit you could form. And that's pretty much how solar panels work, using this concept of just dislodging electrons with enough energy with photons. That's pretty much the photoelectric effect, its concepts and its applications. And I hope that all made sense to you. Have a fantastic day.